Okay, so in this question 6, so we have a circuit here with two voltage sources, and they ask you to find I1. All right, so the first thing is, where is I1? I1 is this current that flows through this 8 ohm resistor. Okay, and you can see that over here you have two resistors in parallel, 20 and 30. Okay, so I can effectively combine this. So I will have 10 volts here plus 20 parallel 30. Okay, so 20 parallel 30, I will get 12 ohm. Okay, and then 8 ohm. And 20 volts. Okay, now what I want is to find this current here, I1. Okay, and what I can do is I can actually just draw, okay, a loop, okay, through this part of the circuit. Okay, since there is no component on this branch that joins it, you can actually just draw two separate loops to analyze this circuit separately. Okay, because there is no voltage drop. Since there's no component in this middle branch over here, there is no voltage drop here. Okay, so this part of the circuit, okay, with the 10 volts, and the other part of the circuit with the 20 volt can be treated as two separate circuits. All right, so all I need to do is to calculate I1, I can draw a loop and just calculate using my KVL loop. So it'll be 10 over 12 plus 8, which will be 10 over 20, which is 0.5 ampere. Okay, now the thing here is, since we know that the voltage is connected this way, the supply is connected this way, the current is going to flow in this direction. Okay, we know the current is going to flow in this direction. Okay, but the I1, the label of I1 is given in the opposite direction. Okay, so since the label of I1 is given in the opposite direction, okay, you must say the I1 is actually negative 0.5 ampere. Okay, so there's a question here, should the loop on the right be anti-clockwise? Okay, so whether it's clockwise or anti-clockwise, again, it all comes back to the same thing, right? Because if I draw it this way, then I would take it as negative 20 volts and negative, and then we will come back to positive. All right, so if you want to draw it in anti-clockwise also can, you don't want also can. Okay, so here will current branch. Okay, so in this branch over here, okay, we do not know what is the current. All right, but we know that there is no voltage drop here, okay, between these two circuits. So because there is no component here, okay, whatever current that flows in this part of the circuit, okay, can be determined just by using KVL over here. Okay, and whatever that is flowing in this is by KVL over here. All right, if there is some component here, okay, that means if let's say I draw some component here, then it's not so straightforward, because then I need to do either node voltage analysis and so on to find out the exact current that flows. Okay, because there will now be a voltage drop experience in this additional component here. Okay, but since I do not have this additional component, that means there is no additional voltage drop experience in the loop that I draw. Okay, so in the left hand side loop, I only see these two resistors. In the right hand side loop, I only see this 3 ohm resistor. So you can treat them as separate circuits. Okay. So the current, like I said, okay, the reason why it has to be negative is because of the question which already label I1 in this direction. Okay, so that is the reason. If they never specifically give you a direction, then you just can say this is 0.5 ampere flowing in, well, either going from right to left or left to right or whatever. Okay, but since they have already drawn an arrow, that means they say that I1 is now going to be referenced in this direction. Okay, but when we calculate, we can see that the actual current is going in the opposite direction. So that is why we now need to specify it in terms of the direction already given to us in the question. Okay, so that is why we put a negative over here. All right, so that is the reason for that. Okay, so it's basically this part here which is connecting both of them. There is nothing here that causes a voltage drop. So because of that, you can sort of treat them as two separate circuits.